How close are we to actually seeing our cosmic neighbours? We've been looking up at the heavens for a long time now, and in the last couple of decades have really been looking into the possibility of life on other worlds. There are a few places in the solar system that are of interest to astrobiologists. Europa and Enceladus are two examples where the conditions for alien life may be just right. However, what about other solar systems? After all, Earth is nothing special. We're just one of billions of planets believed to exist in this galaxy alone. So far, we've only discovered just over 3,000 of these other worlds. Most of them are pretty nasty and couldn't harbour life, or at least as we know it. In the interest of simplicity, astrobiologists look for worlds like Earth using a variety of techniques. There are several methods of detecting planets orbiting other stars. It isn't easy. It was only a few centuries ago that Galileo first saw some moons of Jupiter using his newfangled telescope. It was only about 70 years ago that the first picture of Earth from a very low orbit was taken from a German V2 rocket. This image of our own homeworld is now one of the most iconic images on the planet. Right up there with the golden arches and smiley faces. And we are getting pretty good at getting some nice images of other locations in our solar system. Mars has its own high-res camera on wheels, sending back some incredible images of the red planet almost daily. Seeing planets often hundreds or thousands of light years away though is another matter altogether. I've spoken a little about some interesting discoveries made by astronomers using some roundabout ways to infer details about exoplanet composition. Check out my alien limestone video, it'll get you thinking. Imagine what we could tell about an exoplanet if we could actually see it. Just imagine this, you're an alien examining these images of Earth. You can tell a lot from this picture. You can see ice caps and continents with a range of climates. You can see oceans and clouds and maybe even vegetation, lightning strikes if you're lucky. If, like human astronomers, you're looking at Earth over a period of months or years, you'll see even more. You'll see weather, storms and fires, volcanoes, cyclones. You'll see green, the colour of vegetation. The presence of water alone would have you interested. As far as we know, everything alive needs water. Now, what if this picture was a tiny little mass of pixels, seen from afar? We've managed to actually directly image exoplanets for the first time. This short video from the W.M. Keck Observatory in Hawaii was the result of 7 years of observation. 7 years to get this. It is amazing to look at. If really closely at the planets though here, we realise we can't make out any detail at a glance. Imaging technology will improve. In a way, we've already been able to see a habitable planet from across vast distances. The pale blue dot image shows Earth as just another speck of light in the vastness of space. More detailed images of exoplanets will look something like this at first. This is what Earth will look like in visible light at the lowest possible resolution. Even this cluster of pixels can tell us a lot about the habitability of Earth. Whites, greys, blues all indicate things such as water and possible climate. Seeing this image change over time could be a strong suggestion of seasonality. On Earth, seasonal changes to the planet and atmosphere are strongly linked to the presence of life. See where I'm going? The big problem though with looking at exoplanets is that they orbit these big bright things called stars, which completely block everything else around them. To get around this, the observers who took these images at W.M. Keck used something called a coronagraph. What is that and how does it work? Here's a quick explanation. Go outside and stare at the sun. You can't. You can barely look into the sky, much less make out much detail, because the sun blocks it all. What if a plane is flying past it and you'd like to see it? We'd all do the same thing. we'd put our hand up and block out the sun. With its light no longer overpowering your eyes, you can see quite a lot. A coronagraph basically does the same thing. It blocks out the light of a star, enabling objects nearby to be resolved in much more detail. When missions like the James Webb Space Telescope and others hit the skies, instruments such as star shields will be used. A star shield is theoretical for now, but it's basically an orbital hand, blocking out the light of whatever stars a space telescope happens to be looking at. So there you have it. Obviously technology will improve and will look harder and harder. I hope one day you're the one who's first to see a living, breathing planet. Thanks for watching. I'm Ben and this is Astrobiological, giving you the universe of plain human. Don't forget to subscribe, like and share this video and channel. See you next time.